My name is Izuru Ito. I'm from the University of Tsukuba, Japan. So today I talk about the identification of variation factors for the development of assay using MPS. This is today's topic, the three topics. And at first, the thought process to establish assay method. And second, the case studies for problem solving. And last, third, utilization of international standards. At first, the thought process to establish assay method. When establishing the cell-based assay, we should consider the several things. This is just one example of about the hepatocyte-based assay. So establishing the cell-based assay toward assay method construction, so we should consider the several things. So for example, what specification are required for hepatocyte, or what device should be selected for the assay. So we need we should determine if the MPS is appropriate for the our intended purpose or context of use. Thank you. We reported in the AMED project about this problem. So by the way, the AMED is a Japan agency for medical research and development. So it's a kind of funding agency. And so we aimed at social implementation of MPS as a national project. We create the strategy for establishing assay method using MPS. This is just thought process. So at first, we should consider the intended purpose or context of use. This is the most important point. And the next steps, we should clarify the requirements for MPS. And as we know, the MPS is a complex system. So especially the main two components, it's one needs cells and the other is the devices. So if we want to clarify the requirement of MPS, so we should clarify the requirement of cells and devices. And we do the listing the quality attribute and defining the quality attribute. Finishing these activities, so we can design the assay for optimization and qualification and validation of assay method. Maybe after this process, we can establish the assay method using MPS. This is so in those processes, so we can decompose each phase. So for example, the requirement for cells, so we should consider for example, the specification of organ cells or routine raw materials or availability of standard cells. So in each phase, there are several problems to consider. Okay, the next topic, so the case study for problem solving. In those projects, national projects, we do the multi-center evaluation for assay method optimization. And due to this evaluation, we extracted the variation factors. This is a thought process again. So today I talk about specifically the cell adhesion and the specification of organ cells or protein raw materials. to evaluate the method optimization with the very simple scheme using a common hepatocyte lot. Drug response studies were conducted at 7 institutes. So for example, the university or research institute participating in the national project. So at first, the cryopreserved hepatocyte was seeded and maturated, and we treated the drug for 2 days. After treatment, we check, for example, the metabolic enzyme mRNA expression. This is one of the results. So the CYP3 mRNA induction by drug treatment. So this graph is mRNA, normalized mRNA, normalized mRNA. And we are really surprised that this result, because there are many differences, the absolute value of the mRNA expression level. So the low or medium or high. And by the way, this is a gray bar is control, and the red bar is rifampicin treated. So the induction is correctly, but why this trend? So we examined the culture reported from 7 institutes in detail, and we extracted the difference between the induction days and seeding density in process. So whereas the induction days, 2 days is correct, but 3 institutes is only 1 day, or the seeding density is slightly different. So this difference is correlate to the mRNA expression level. This is a brief summary. So the drug response testing procedure, so that the following factors, seeded cell density or drug treatment time, were found to cause variation in the method of measurement. So the problems were found in the creation of procedure manuals. This is just the reflection, and other aspects that we found a point to keep in mind when educating operator. So for example, the seeding time on and so on. After the multi-center evaluation, in order to evaluate these variation factors, we do the evaluation of the impact of seeding density. This is a very similar scheme to the beginning evaluation. So the ability of hepatocyte seeded at 3 different density to induce ship mRNA was analyzed for various hepatocyte cell lots. And seeding density is 3 concentration. This is one of the results that the CYP3 for mRNA induction. We do the 3 vendors cryopreserved hepatocyte. So these 2 results is slightly similar, and this result is just slightly different. And there is an optimal seeding density. And we know the effect of seeding density on hepatocyte adhesion. This photo is a high concentration seeding. And this is a medium concentration. So cells detach at high seeding density. So this is one of the reasons of variation. There are other point is a difference in culture image from hepatocyte strain to lot. The center of hepatocyte is different pattern of induction. The morphology of this lot differ significantly from other lots. So maybe the conference changes. Next evaluation is evaluation of the impact of induction days. We do the similar theme, and drug treatment days is 1 day, 2 days, and 3 days. This is one of the results that the CYP3 whole mRNA induction. So about the 3 different cryopreserved hepatocyte, the same pattern. There is an optimal induction days. In this case, the 3 days is optimal. The brief summary. So the variation factors in the assay process, the number of seeded cells and induction period were found to affect the performance of hepatocytes. It was shown that the consideration of cell adhesion is necessary, and it is necessary to consider the property of frozen hepatocyte, which are the raw material. So we do these considerations toward construction of robust assay system. Okay, so this is the last topic toward utilization of international standards. This is a very interesting review in bioengineering. And in this review, there is the availability of existing standard documents. This is a very, very interesting data. So in this data, there are no standards for assay method using MPS. However, I would like to make the small suggestion. So the example of a standard document that can be utilized. This is one of the ISO standard, the ISO 23033. This document is the general requirements and considerations for the testing and characterization of cellular therapeutic products. This is, yes, this scope is for cellular therapeutic product, but we can use cell for MPS. I explain again about this sort of process, and this standard ISO 23033 can be used in this process, optimize, qualify, and validate assay systems using MPS while accumulating data. Today, I talk about variation factors, extracting variation factors. Example used for variable factor extraction, we can use the ISO 23033. This is a figure in this document, and it's the Ishikawa diagram illustrating common sources of variability. And in this diagram, so for example, the cell source or procedure, this is connected to the variability in test using MPS. So I use this document to extract the variation factors in our hepatocyte-based assay. So last summary, so that even if there is no MPS specific standard, but the existing documents such as concept may be utilized. On the other hand, the standards specific to MPS are also necessary, I think. First of all, it is necessary to promote international standardization using, for example, the white paper and so on. This is acknowledgement. Many researchers, student organizations contributed to this project. And this is the last slide, so very important information. So today I'll talk about the variation factors about cell-based assay in MPS. So these poster session and roundtable is related to today's my presentation. So please check this presentation. That's all. Thank you very much.
Thank you very much. Are there questions from the audience? I have one question. You tested the different variation factors on the 2D model, or like of a 2D cell hepatocytes. Have you also already investigated more complex systems, like 3D models or co-culture with other cells to understand the variations there?
Yeah, it's a very great question. So now I tried the very simple system, but I understand that we should do the next, as the next step, the more complex system. But I think at first we should identify the variation factor in simple system, and this is a base. This is a base information to create the complex to extract the variation factor in complex system. So I think it's a step by step.
Okay. Where do you expect, if you go to MPS and you have microfluidic setups, etc., where do you expect big challenges or variation factors in the future?
Yes. So today in this summit, every people says about several devices, several materials, several cells. So, and the MPS is just a complex system. So most challenging point is a combination. So the very variable, there are very variable combinations. So the exactly the general variation factor is really challenging, but we should challenge about this.
So I believe there most probably first needs to be kind of a standardization before we can look at the variation, because as has been discussed during the lunch session, we will have, at the moment, we have a big landscape of a lot of different systems. So it might be difficult to find the common factor to then understand which of these factors is actually creating most of the variability. How do you deal with this large amount of different systems?
Yes, it's a great question. So I totally agree with your comments. So the one of the most important point is we should same sort of process. And so the dialogue is really important. So we can, if we get the several data to common process. For example, the data management is really important. So data format is really important. So if the data format is a common, so we can discuss, we can do the dialogue. So this is the most important point to achieve the extraction of variation factor in complex system for you, I think.
Any questions? You mentioned white papers. Who would be the ones who write these white papers? So whom do you expect to write white papers on the variation of?
by the way, I talked in this presentation, we prepare the white paper in national project, and I think the reader is, for example, the MPS supplier. Yeah, because the MPS supplier is slightly confusing how to create the MPS depending on user requirement system. Yeah, user is, for example, the pharmacopoeia. So the white paper is, I believe that as guideline, the white paper is working. So, so at first we prepare the white paper for MPS developer, but yeah, this white paper is, of course, the other target. So, for example, the user or researcher. At first, MPS developer, first target is MPS developer, I think.